Hey guys, it's Vince. Today in this video, I am excited, as many of you are, as I've gotten more messages on this system than virtually anyone I've produced, in doing the actual testing as far as what we're able to see it perform with a motor attached to it. Now, of course, this is not attached to a transmission. That being said, steppers do bleed torque as they accelerate, meaning the faster it spins, the less torque it produces. But either way, it would be arbitrary in the sense of telling you what amount of torque we're able to produce at what RPM, because each transmission is different. So that one variable throws a lot of testing off without this motor, or any motor for that matter, being attached to your specific transmission. Either way, it will give you a definitive idea of how advanced this system is and what it can do. And that's the good news. And why I say it's the good news is every time we engineer something and start with prototypes, there's always little hiccups. That's just the way engineering is. Many of you know that. That being said, the bad news is this X-axis drive works great, but the pinout on the DB25 we figured out is off on some of the pins and not correlating correctly with the IDC for the UC400. So that being said, we are redrawing the connector up so we can get the pass-through of the pins to be exact so we don't have any issues. It's kind of unfortunate because the graphics were done on the system already. They'll have to be redone, but I love engineering in the one aspect that if I do my testing right on my end, it means that you guys don't have to worry because I've already found all the glitches and then we correct it and you get the product that you're expecting. So right now, I've got the fans disconnected. I'm not going to do an edit on any of the motor testing because I feel that that would be kind of a bias. I don't like any question as far as what we see being done here. But many of you already know most steppers top out at between 2,000 to 3,000 RPM. That's usually the limit. I think you're going to be impressed with what you see here. Let's power on the system. Once again, fans aren't engaged. All we're actually hearing right now is our motor. It does have some stepper sing. I did not go into Mach 3 yet. I'm going to go into Mach 3 right now. And we got the UC400 and it's active. Now you notice, I'll be quiet, the stepper sing is gone. Just to clarify, my Nema 23, 600 ounce, 3.5 amp motor connected here. Tachometer, I'm not going to move it because if I move it, it'll readjust the distance to the tracking tape on the end of the motor so we can get an accurate RPM. Many of you, like myself, I think are going to be impressed with what you see, and you're going to learn something that I didn't know myself. I think many of you are going to like this because doing real-world testing with a tachometer, it eliminates a lot of the fudging that goes on online when you're dealing with calculators. And believe you me, I went on ChatGPT. I was using all kinds of calculators and coming up with ridiculous numbers with what I was able to achieve. So rather than do that, we'll just use a real tachometer and see the truth of what this is able to do. So that being said, we're just going to come in here, click on reset. Everything here is all configured as far as for that X-axis to run. I'm not going to mess with anything. We're going to go right into plug-in control. And the reason I'm going into plug-in control is I want to show you guys I am running the UC400 at 200 Hertz. That being said, many of you don't know that the UC400 can actually operate up to 400 kilohertz. And your kilohertz ratio is how fast those step and direction signals can go to the motor, and that produces more speed. This system is extremely capable of at least 200 Hertz, and therefore that's why I'm starting there. So very, very powerful in itself. We'll go right there, click reset. And now what I'm going to do is go into config, motor tuning, and we are going to go real simple. We will start at, let's say, 1,000. Well, right now that's set at micro stepping of 10 times, so it's 2,000 steps per revolution. And we're staying at a velocity of 1,000. Now, many of you already know Mach 3 will auto-adjust this number. It'll be slightly off, like 999 decimal. And acceleration, we're going to leave at 35. I'm going to leave this just as many of you would leave your system. Meaning once you find the acceleration point, and acceleration just simply means how fast it comes up to the travel speed, then if you find smoothness, you can leave that. 35 seems plausible, so we'll leave that. I'm not going to mess with that, and we'll start at 1,000 and see what we're able to achieve. So I'll click on Save Axis. Here is 1,000, and click OK. So we'll start the jog. See our motor jogging right there. Now I'm going to shoot it with the tachometer. And we should get a number reading shortly. There we go. See if I can get it dialed in. Distance. Right there. Okay. Now I want you guys to pay close attention to this because I really ran this test numerous times and I noticed something many of you may not have noticed is that the inches per minute on within Mach 3 are registering in RPM. If you look at the tachometer, we're at 1,000 RPM. If you look at the units per minute, we're at 1,000. She's focusing on that right now. You can see the consistency and we're set. So 1,000 inches a minute, nothing new. Many steppers do that. It's well within the operating range. Let's continue. And you can see it did adjust. Went to 1,000.2. Sometimes it goes a little over, sometimes it goes a little short. That's just Mach 3. We're going to go to, let's go to 2,500. Still well within most stepper range, not adjusting steps per. We'll still leave the micro stepping at 2,000. Acceleration, once again, not touching, just messing the velocity. Save axis, you can see our bar graph once again go way up. And we're going to click OK. And let's start the jog. Definitely hear a tone difference. There you go. 2,500. Oh, let it adjust. There it goes. 2,500 RPM, 2,500 inches per minute through Mach 3. Once again, look at the tachometer. We were at 2,500, and we're at 2,500 within Mach 3, under inches per minute. Okay, once again, well within stepper range. You hear the motor turn off, and that's due to the fact that the drive, once again, detects that the motor is not in motion. It's just providing holding torque. It reduces current power, and it's working in silent mode, and you can hear that. Or I should say, you can't hear that. She gets closer to the motor. There you go. So let's see what this can do. I'm going to come up again to config, motor tuning, and I'm going to go now, let's go 3,500. Many of you already know most steppers max out at usually very close, if not even with 3,000 inches per minute. And when I say inches per minute, I think we all know now that inches per minute translates to RPM within Mach 3. We've just seen it. We'll see it again. So I'm going to go 3,500, which is really excellent. Most drives cannot achieve that. Let's see if we do not adjust, once again, micro stepping, we'll leave it the 10 time, providing 2,000. Acceleration, once again, at 35. And we'll click on Save Axis. See how everything has basically been readjusted. We'll click OK and begin the jog. Once again, we hear the tone difference. 3,500 RPM right there. Let's let it readjust. 34.99 to be exact, and 34.99 within Mach 3. You can check it right there on the screen. Now guys, this is super impressive. Whether or not this motor naturally can hold torque and provide usable motion at that RPM is really not as relevant as the fact that you will get a percentage of that for rapid motion, meaning when you're just moving your axis, going from one point to another to begin machining, naturally that's when the machine works the fastest because it's trying to just go where it needs to go to continue the machining process. If the machine is unloaded, you still have a more usable amount of RPM to naturally go and jog that machine to get to those locations faster, which once again provides faster machining time. Let's see if we can go faster. Go under config, motor tuning, and now I'm going to go, we're at 34.99. Once again, Mach 3 adjusted that. Let's go to 4,000. Save axis settings. We see the peak on our bar graph. Once again, microstepping left the same at 10 times or 2,000 steps per. Acceleration left the same at 35. Click OK. Let's begin the jog. Definitely hear a tone difference. See if we get a register. 4,000. 39.9, 4,000. Let's see if it'll register again. Here we go. 4,000 inches per minute through Mach 3, 4,000 RPM on the motor. 4,000 inches per minute, Mach 3, and once again 4,000 RPM on a stepper motor. Let me be concise. This is a stepper motor doing 4,000 RPM. Now, in all fairness, Pitar did this in his video, and I believe it was either a Nema 23 or Nema 34, and he was able to achieve 4,000 RPM. So let's see if we can go faster. Config, motor tuning. Let's go 5,000 RPM. And you know and I know the odds of you being able to use, once again I'm stating this so there is no confusion, I'm not using smoke and mirror games. The usable RPM will be usually much lower than 5,000 RPM. That being said, how much lower we don't know because it's not connected to your specific transmission. But either way, you have a huge gamut of what's totally available or what's considered available on a stepper motor, if this is even possible. Steps per left again at 10 times micro stepping or 2,000 steps. Acceleration still left at 35.25. We're going to save the axis settings now. We'll watch the bar graph. Look at that bar graph. Interesting. Let's click on OK, and let's see if this will hold it. Definitely a difference in tone. Let's see if we hit it, and that's 4,999. Let's see if it'll go back. There it is. 4,999. Checking the inch per minute on the screen for Mach 3. Registers the same. That's 5,000 inches a minute, guys. Or technically 4,999. So let's do this. Let's see where the envelope is. I'm going to hit motor tuning again. Now, we're going to come over here. Go 5,500. Once again, steps per 2,000. Once again, 10 times micro stepping. Acceleration, once again, still set at 35.25. Going to 5,500, save axis. And you guys will notice I just saved the axis at 5,500 and it went down to 5,100. So, believe it or not, this is Mach 3's envelope. The software will not allow us to go any higher than 5,100 inches a minute. This is interesting. This will definitely be a record. I don't know of what world record, because technically I've never seen a stepper myself personally go this fast. Regardless of it being loaded or not, this is really impressive. I hope you guys appreciate what you're seeing, because if you go and do a search, even through Google, through most of the online research, steppers top out, we know, at about 3,000 RPM. Once again, whether this RPM is totally usable, that's negatable, but looking at this is amazing, because this motor in theory should be stalling well under this. Let's see what happens. Starting to jog, let's see if she holds it. I'll go to 0 this time because we're far away. Definitely hear a tone difference. 5,099, let's see, it just loaded, there it goes. 5,099 RPM. 5,100, 5,099 through Mach 3. Look at how fast it's covering that distance, guys. Pretty incredible. Something else to consider, and I cannot reiterate this point enough, this system is only calibrated at 50 volts. And it can go comfortably up to 60, and that's still under its top out at 65, which I don't see really being required. We're already topping out right now. And that's not topping out the motor, that's topping out the motion control software. So you've seen it live. No edits on this, you're seeing exactly what's achievable. Let's see if it hits dead nuts on going back to home. It is flying. Once again, pay close attention. Your inch per minute through Mach 3 and deviation on your tachometer. Very, very minute. There you go. What's interesting, and I want to point this out, you notice that hit 0, which means even though this motor most definitely will not be using 5,000 RPM achievable with most transmissions, mainly due to the fact that steppers, once again, lose torque the faster they go. It's so interesting to point out and demonstrate live. Number one, we just seen RPM is definitively matched with Mach 3 motion control under inches per minute, but we also got to see the operational envelope of steppers in terms of what we've heard about how when you operate them, they miss steps. This motor did not miss a step at 5,100 inches a minute. It came right back to home. So you think about that, it's pretty incredible what we've just seen. Okay? Now, once again, once this unit is fully completed, again, I'll do a follow-up video as everything is coming to fruition. But seeing the system now and what you can expect out of a stepper-based system, and once again, guys, I'm only running 1/10 microstepping or 10-time microstepping. Okay, so we can go up to 256. I have it set at what a G540 would be. And I can tell you, I have never in my life of working with automation at all have ever seen a stepper achieve that kind of RPM. That is amazing. Let alone doing it at 50 volts. That's truly amazing. So keeping in mind how many of you have asked me questions, what kind of performance can I expect with that system on my router or my mill? Think about what you just saw. Whether or not you get even close to that RPM, let's say out of the 5,100, you do get 3,000, which probably is close to what you'll actually receive, maybe even a little over that. That's still amazing. because that's usable torque. I mean, that's usable in the sense that you're able to not necessarily machine with, of course, but able to do rapid motion, which means it's going to speed up your manufacturing process massively, and all with using a 50-volt power supply. So amazing what we just saw, and hopefully you guys will stay tuned, and I will do the update as we get the DB25 sorted out, and in this way you can see exactly what's going on. I'm going to cut over now.
Yeah, I don't believe in destiny, I just do what's best for me. Don't listen to my enemies, they're just full of jealousy. Yeah, this legacy, you gon' see what's left of me. You gon' see success in me, you ain't seen the rest of me. I just wanna be the best at what I know, better than the rest, just watch me grow. Put me to the test and watch me go. This is my quest, I'ma make it known. They call me obsessive, oh I know. Call me selective with my notes, call me aggressive with my flow, call me offensive even though yo, I ain't gonna lie, life's tough. Try to get by, life's rough. Try to do it right, it's not enough. Even though you try, you still mess up. But I'm still gonna fight for what I love, still gonna die for what I love, still gonna try, I won't give up, still gonna fight until I've won. They say I'm way too obsessed and I've got nothing left, and I'm not quite there yet, but those words they'll regret, cause I've got something left and I'm not giving in. I will not let them win, I won't stop till the end, no. Some injuries, mentally and physically. Studied them religiously so I don't repeat history. And people won't admit to me they don't want a victory bad enough to get a C. They'd rather just go leave it be. And oh, this journey I've been on since 13, working hard and learning, never stopping searching. Yeah, it's burning, all this passion hurts me. I took action working, writing down these words. No, I'm not okay, I just wanna be something. I don't wanna be nothing, living all alone. No, I'm not alright, I'm just barely getting by. But I'll tell you I'm just fine, so you leave me alone. They say I'm way too obsessed and I've got nothing left, and I'm not quite there yet, but those words they'll regret, cause I've got something left and I'm not giving in. I will not let them win, I won't stop till the end, no.
Okay guys, you can see the connector pinout right here, and we do have the DB25 connector that the unit is using. You can see the solder pins right here. Now the SMCU-4 was natively using an IEEE 1284 connector, and we brought it over to the DB25 you see before you, and that's so it can integrate with the UC400. Well, in doing so, the way the original connector was pinned out was 114, 215, 316. You can see how this is all broken out, and then it comes over here, and we are having a configuration issue with the way that this pinout is with the IDC26 cable. Now that's the ribbon cable that communicates with the UC400. So what we're doing right now is Batar is going through and we're converting it over to a typical DB25 pinout, where once again we go from 1 all the way to 25. And you can see that in the green numbers right here versus the red. Once that's done, we will have the proper communication set up so that the UC400 will stay in conjunction as far as its pinout configuration directly with the SMCU, and we will have a perfectly running drive so that all the features work. And once again, I want to thank you all for your support. and watching the video. I hope that this type of engineering video keeps you guys well informed on what you're seeing in the future. I get a lot of requests for them, and I'm doing my best now with the new move as far as getting everything set up to really cover these in more detail, because I know a lot of end users like seeing this process. How does it go from idea to finished product? I myself find it really interesting. I'm a geek by nature, and it's just something that I've always found super interesting, and I love engineering, and seeing this come together where mistakes are always going to be made. And that's why I tell you guys there's no such thing as an expert in this field or any of the professional fields. I think you're always learning. It's a practice. Doctors practice, lawyers practice, accountants practice, engineers practice. That's how you hone your skills. Are you ever an expert? I don't believe that exists. I think everybody makes mistakes. It's unfortunate we have to correct this, but like I said, I'd much rather do this in my possession than in someone else's. So again, I want to thank you all for your support. Take care.